Let's discuss part 2, that is risk and consideration of using a bearer tokens. Bearer tokens have characteristics similar to the session cookies used in browsers. Unfortunately, misunderstanding this parallelism leads to all sorts of security problems. When an attacker is able to intercept an access token, they are able to access all resources covered by the scope of that particular token. A client using a bearer token doesn't need to prove possession of any additional security items such as cryptographic key material. Apart from the token hijacking, the following threats associated with the OAuth bearer tokens are common to many other token based protocols. Yeah, so it's basically if someone intercepted our access token, then they're able to access all the resources covered basically by the scope. That means that token, whatever the scope of that token, based on that you can able to access the resources, and then there is no other thing you need to prove while accessing the resources talking about. And there are other like threats also associated with the OAuth bearer tokens, and it's common to many other token based protocols also. So one is token forgery. So an attacker may manufacture its own bogus token or modify an existing valid one, causing the resource server to grant inappropriate access to the client. For example, an attacker can craft token to gain access to information they were not able to view before. Alternatively, an attacker could modify the token and extend the validity of the token itself. Okay, that can be happened. So you have a token, attacker just created a bogus token and just modify the validity time. If it's valid for 1 hour, I can just extend that and I can use the resources. Right? If there is no validation happening at the resource side. Token replay. An attacker attempts to use an old token that was already used in the past and is supposed to be expired. The resource server should not return any valid data in this case. Instead, it should return an error. Yeah, if you use the expired token, it will definitely return an error. In a concrete scenario, an attacker legitimately obtained an access token in the first place and they will try to reuse it long after the token has expired. So, because the attacker have the token, so we'll just try to reuse it long after the token has expired also, right? By just again that extending the validity like those things. Token redirect. An attacker uses a token generated for consumption by one resource server to gain access to different resource server that mistakenly believes the token to be valid for it. In this case, an attacker legitimately obtains an access token for a specific resource server and they try to present this access token to a different one. So yeah, maybe this is one of the thing, right? So in this case, like I can just access to other resources also that is not entitled, because again that resource is not sure on that, right? Yeah, or it just trusted that token is valid and just allow the resource access. Token disclosure. A token might contain sensitive information about the system and the attacker is then something that they could not know otherwise. So information disclosure can be considered a minor problem compared with the previous one, but it's still something we need to care about. So these are the problems we see, right? Whether token forgery, token replay, token redirect, token disclosure. So yeah, so something has to be done here to remove to just fix this problem, and that's what we are trying to understand in this case, and maybe in the coming session, like after this session. So these are the problems, right? So if somehow the token has been intercepted or it can be hijacked, how it can be stopped now to use it further, or how we can mitigate it, right? The foregoing are all server threats that apply to tokens. How can we protect bearer tokens at rest and in transit? Right? Security as an afterthought never works, and it's important implementation makes the right choice in early phase of any project. Correct. Yeah, we just need to put some correct implementation so that we can stop. If somehow the token can be hijacked or intercepted, it can't be reused or it can't do any much thing, right? So we can save our system. So this session, yeah, it's just like for that part only, but yeah, let's discuss in the next session to understand more. Okay, yeah, if you have any question, please put in the comment section. Yeah, thank you.